this video, I would like to discuss the relationship between radical form and rational exponents. Here I have a radical expression, and I have x at the nth root of x to the m power. That is equivalent to x to the m over n power. This ratio, this fraction in the exponent being what we call a rational exponent for that. So here we have this little formula, little trick for converting from radical form to rational exponents. It's not that difficult to do. Sometimes people get confused what number goes where. With that, I tell people this to kind of keep it straight. This n, this index, tells me what root I'm taking. Trees are something that I see quite commonly. I know where to look for the roots. They're at the bottom, right? I don't see very many trees unless something weird has happened where the roots are sticking way up in the air like that. So the roots are at the bottom. I expect them to be going down into the ground. So if you look, this index here becomes the bottom number of this fractional exponent, of this rational exponent. So that's always what I would say to kind of help students with this. I would always draw this picture on the board, and I would say, this looks normal. I would draw a tree, something like that, and I said, what are these? And they say, oh, those are the roots. And I said, okay, well, which of these would you expect to see? Would you expect to see that, or would you expect to see something that looks like this? And then they always laugh and they joke and they say, that's ridiculous, not unless a tornado's come through or something like that. No, so this here is ridiculous. We definitely don't have the tree upside down like that. We have the tree looking like this. The roots are on the bottom. That was always my little visual aid to help students remember that the index tells you what root you're taking and the roots go on the bottom. So when you convert from this form to this form, that number that's telling you what root to take goes on the bottom of the fraction. I don't know if that'll help any of you or not. Maybe I just showed how terrible of an artist I am. That's fine. I don't really care. Trust me, I can do much better than that. And I actually feel like that's something I can do fairly decent at when I actually try, but I didn't put a whole lot of effort into that right there. So now let's take a look at how we can actually use this to convert from radical form to rational exponents, or the other way around. Okay, I've thrown together a couple quick examples here, and I just want to convert these from their current form to the equivalent form, whether that's from radical form to rational exponents or rational exponents back to radical form, just so you can see the connection here. So here I have the square root of 3. There are some numbers that are assumed to be there that aren't written in, so that's why I did this particular example. When you don't see an index number written there, remember that it's assumed to be a 2, and when you don't see an exponent, that's because it is assumed to be a 1. So now that I've penciled those in, I'm going to keep this 3 here, and to figure out what its power should be, I need to make a fraction out of the index and the exponent. Again, remember maybe my example about the tree will help you. The index tells you what root you're taking. The roots of trees or plants are at the bottom with that, so the 2 would go on the bottom. So this would be to the 1/2 power, like that. Here I have something written with a rational exponent already, and I want to convert it back to the radical form. So I look at this, and I say, okay, the bottom number tells me what root I'm taking, so this becomes a 5th root of x squared, like that. And then down here, again, kind of like the first example again, I'm going back from the radical form to the rational exponents. I have y to the, and again, I have to make a fraction out of these numbers. Remember, the 7 out here is the index. That tells me what root I'm taking. It's a 7th root, so that's what goes on the bottom of the fraction. So that should be y to the 3/7 power would be the equivalent of that.